In this presentation, you will see that TCP/IP consists of a variety of protocols, each of which has a specific role in transmitting and receiving data over a network. The OSI model is divided into 7 layers, 6 of which are consolidated into the 4 layers of the TCP/IP model. They are application, transport, internet, and link layers. Software to interface with specific network topologies is not part of TCP/IP. Each of the upper 3 TCP/IP layers contains one or more protocols that perform different functions within TCP/IP. 6 of the most commonly used application layer protocols are Telnet, which is used to log onto hosts remotely, FTP, the file transfer protocol that can be used to copy files over the network, SMTP, the simple mail transfer protocol that makes it possible for you to send email over a network, DNS, the domain name system that is responsible for looking up a host's address so that you can connect to it, RIP, the routing information protocol used by routers to trade information with each other, and SNMP, the simple network management protocol that enables you to manage servers and other hosts over a network. There are 2 protocols at the transport layer. TCP, the transmission control protocol, is connection-oriented, which means that it maintains a connection between the source and recipient hosts until a packet has been successfully transmitted. It uses the connection to check that a recipient is ready to receive a packet, to acknowledge to a sender that it has accepted a packet, and to request replacement packets if it determines that data it receives is corrupted. TCP is called a reliable protocol because it ensures that data is transmitted accurately. UDP, the user datagram protocol, is a connectionless protocol. When it sends a packet to a host, it does not check that the recipient is ready, and when it receives a packet, it does not acknowledge it. Because it does not send the large number of messages that TCP uses to ensure that packets are delivered, it requires much less bandwidth than TCP. UDP is used by application layer protocols such as DNS to transmit short messages such as errors and queries. UDP rejects corrupted packets but does not report the bad packet to the sender. Many applications that use UDP request that a packet be sent again if they do not receive one within a specified time. Because UDP does not guarantee packet delivery, it is often called an unreliable protocol. Streaming media often uses UDP because of its low overhead. Most media players buffer enough of the arriving data to be able to request a new copy of a bad packet from the sender and receive it before it is needed. The Internet layer only has one protocol, IP, the Internet protocol, which manages the movement of packets between sending and receiving hosts. It is responsible for dividing packets into sizes that will fit through the routers on its path, addressing the packets, and routing them to their destination. IP includes several other protocols that it uses to perform some of its tasks. It uses ARP, the Address Resolution Protocol, to find destination hosts, IGMP, the Internet Group Management Protocol, so neighboring routers can keep group address lists current, and ICMP, the Internet Control Message Protocol, to carry messages such as errors and queries. TCP/IP does not require a specific network topology. It uses functions at the link layer to build packets that match the requirements of the network to which it is connected. The hardware interface is managed by the network operating system. Here is an example of the way TCP/IP protocols work together to perform a simple operation. A co-worker has emailed you a link to a document that is on a different host. When you click on the link, your application uses your client to request that the name server send the IP address of the destination host. The name server uses UDP and ICMP to build a small packet to request the IP address of the host you want to connect to. Link layer functions build an Ethernet frame and pass it to the network operating system. The name server sends back a packet with the target host's address. It comes in through the link layer, goes through the IP layer where the routing information is stripped off, goes back through UDP where the packet's integrity is checked, and then back to your application. Your application uses your client to send a request to the target host's IP address for the file that you want. It uses TCP for a reliable data transfer, goes through the IP layer and out through the link layer. The target host uses TCP to segment the file you want into packets and send it to your client. Each packet comes in through the link layer and passes up to TCP, which verifies the data integrity and holds it until all of the file segments have arrived. It also acknowledges receipt of the packet to the sender. This cycle repeats until the whole file has been reassembled. If a packet arrives that does not pass the integrity check, TCP discards it and requests another copy from the sending host. When the last packet arrives, the file is reassembled and passed up to the application layer where you can access it. In this presentation, you have seen how the TCP/IP protocols perform the different tasks needed to move data around a network.